we're asked to factor each of the given polynomials. But before we do this, let's take a look at the rules for this. We recognize this to be a difference of two perfect squares. So in this case, it states that any binomial that is a difference of two perfect squares can be factored using the following form. A squared minus b squared equals a plus b times a minus b. So we're going to use this information to factor the polynomials. So what I always tell students to do is simply take the square root of each of these to break it up. So the square root of x squared happens to be x. So I'll say then, write x plus and x minus. Now, the missing part happens to be the square root of the second term there. In this case, the square root of 25 is 5. So we fill in a 5. So x plus 5 times x minus 5 are the factors. And when multiplied out, we should get x squared minus 25. So this is our answer for the first example. Now looking at the second example. Again, we follow the same procedure. The square root of a y squared is y, so I'll write y plus and y minus. And the square root of 36 happens to be 6, so I'll write 6 here and 6 here. So my factors then are y plus 6 times y minus 6. Again, when multiplied out using the FOIL method, will give us y squared minus 36. Now, looking at the next part. First, see if you can't factor out a greatest common factor for this. Well, we notice here that for 27 and 3, the greatest common factor is 3. And for a cubed and a, the greatest common factor is a. So then what we're left with inside happens to be a 9a squared minus 1 inside the parentheses. Again, if you were to distribute this in, you'll get 27a cubed minus 3a. Now, follow the same procedure as before, recognizing that this is also a difference of two squares. So, we'll carry this 3a straight down. The square root of 9 is 3. The square root of a squared is a. So I'll have 3a plus and 3a minus. Now, the square root of 1 is 1, so I'll put in a 1 here as well. So now I have factored my given polynomial. Using the property of a difference of two squares, first I factored out the GCF, and then I factored out the difference of the two squares. So that is my answer there. Remember not to forget the 3a that you had initially pulled out as the GCF. Looking at the next example, again, check to see if you can't pull out a greatest common factor. Well, in this case, we have 2x squared minus 32y squared. Okay, the GCF happens to be a 2, so I will have x squared on the inside minus 16y squared. Now, I'm going to bring my 2 straight down because that is part of my answer, and I follow the rules for the difference of two squares for what was remaining on the inside of the parentheses. The square root of x squared again is x, so I'm going to write x plus and x minus. Now, the square root of 16 is 4, and the square root of y squared is y. So I will write plus 4y and subsequently minus 4y. So there you have it. You have factored this one also using the property of difference of two squares. Remember that first we factored out the greatest common factor, which was a 2, and we carried it straight along because it's part of our answer. And then we factored what was left inside, since this was a difference of two squares. So, good luck.